Hello, everyone. Welcome at our regular core protocol sync. We'll talk about changes to the protocol from the last week and what we are planning to do next. And the first one to share updates today will be Ivan.
Yeah, sure. Let me share my screen. Yep, here it goes. So basically, during the last week, there were like minor pull requests. One of which was like updating PartyDB. Like we are depending on it, but yeah, we introduced some changes to that, and it was propagated to release finally. Yeah, pretty minor thing. Apart from that, yeah, we also pushed some changes to PartyDB, like getting the debug implementation to almost all public structures. And other things. Yeah, so we could like easily derive debug for the PartyDB. Of the structures which include PartyDB in it. Yeah. Also, I've been working on the benchmarking the memory usage of the PartyDB and on the farmer end. Yeah, it seems that especially on Windows, we struggled with that because of the because we didn't use the JMalloc allocator. Yeah, it seems to handle the PartyDB and small allocations better. But thing is, what we discovered after messaging with the party guys that the batch size actually matters a lot. And the basically decreasing that for commitments helps with the memory usage a lot. So yeah, I was benchmarking that, and it seems to work fine. Yeah, I guess Nazar will talk about it a bit later in more in depth. Apart from that, I've been working with telemetry. Yeah, we've been planning with Nazar a bit here today. Yeah, I can talk about it in depth, or we can move on to the move a discussion to the AppSync. What do you think?
I think it's more for the AppSync and also just treat my comments as suggestions. You'll have to discuss it with Arthur about what we'll actually do. Just like my input.
Totally. Yeah. Thanks a lot, though. Um, yeah. And also apart from that, just to mention, I guess we'll talk about with Jeremiah this week. Yeah. I also put some comments on the Wrapper API. Yeah. I had an idea of like doing the like second take, like from like how I see it on my end. Yeah. Just reworking the whole page here and leaving it this one as it is. Yeah. So
Can you maybe briefly describe what it is? I'm not sure everyone knows.
Oh yeah, sure. Yeah. So this is basically the API, which we will have like in order to like start the node, like different things, getting the introspection of the node and above node and farmer. So basically, uh, this should make more sense here. Basically, we'll have some TypeScript code, and like this Wrapper API will allow us to like, for example, to start the node, supplying it with the node type, network name, node name, like just opening it in some directory, syncing it. Yeah, same goes for the farmer. Yeah, we can just apply some reward address, some space pledged, etc. And like we can sync with that manually. Add some headers, etc. Yeah, which just basically would help to bring us to it would help us to have some toolings, and apart from that, that would allow us to have better desktop app in future.
You want to back up one up to the document above this and show that diagram, the architecture diagram.
Oh totally. Yeah. Where it is?
Just click up to the top where it says Subspace Wrapper SDK. There you go.
Yeah, here it is. Yeah. So basically, this is supposed to be like an more of an abstract API, but we're still discussing it in terms of like the TypeScript bindings, how they would look like. Yeah, but this is supposed to be like very abstract. This is where it sits. So
the idea here is to have just not impact the monorepo at all. It's just a wrapper around the monorepo that just tries to simplify the notion of running a node in a farmer and define a standard simple API. For doing that, we're going to first define that API, then implement it in Rust. Oskin would be working on a CLI of that in Rust, but the goal is to eventually use that Rust library as a way to bind it into TypeScript and then have somebody on Arthur's team build like an npm package for like a Subspace SDK that will be like the new kind of standard CLI that we'll use.
Yeah. Thanks a lot, Jeremiah. Yeah, so that's it on my end. I guess I will mostly work on the telemetry and the Wrapper SDK, Wrapper API. Yeah, that's it on my end.
Comments from anyone? Everything is clear. Okay, Shamil, what's happening on your side?
Sure. I was working on the description of the first version of the distributed storage network. I will share my screen. Something is not working. Let me try again. Can you see it?
Yes, we can.
So the first version is of this document is just for describing what we have now, the first version of the distributed storage network. It will allow us to, for Daria mainly, to create a formal specification of it. I described what we have now, what requirements we have, presented some high-level architecture for the nodes we have, because we have currently kind of overcomplicated design, I believe, for that, because of relaying nodes. I specified what kind of algorithms we use from the P2P protocol stack, what kind of node types that I mentioned we have, what algorithm we implemented on top of that stack, and what basically we do with all these algorithms. But now I finished the second revision of the document, and I switched to the design of the second version of the distributed storage network. There are multiple questions here. Basically, the draft, the very first draft, I enumerated major layers of the future design that we will have, some major problems that we need to solve, like how we will do the object retrieval or how we'll work with object mappings. What layers will we have in our network? Caching layer, some additional layer for pieces, for decoded pieces that we will have in our consensus, and what kind of algorithm we will have for archival storage layer. These questions are early stages discussion. We need to discuss all the issues we have. I enumerated numerous algorithms, and we should narrow down to most efficient design. We will have multiple discussions, probably this and next week. That's it. I'm open to questions.
I think Shamil, just one comment. Sorry, go ahead, Daria.
Yeah, I was just saying, I guess I will going to have a lot of questions for you later
Sure,
when I'm actually going to go
just
through it.
I believe that you will start from the first version.
Yeah, and Daria, the idea here between the V1 and the V2 is that we're probably going to retain most of what's in V1. We're just going to be adding onto it. So it's still important to specify the V1. That'll be easier to start specifying that. It's a simpler design. And then once we have that formalized, then we can start extending it into the V2. There will be some parts that will get removed. There'll be some new parts. There'll be some parts that get elaborated on, but it's not going to be a completely different design.
Like, Shamil, if you could, in like 3-4 words, describe what are the stages of this. So, for example, for consensus, we have like archival, then we have plotting, then we have proving, and we have verification. for instance?
I
What
think
would be the
it
sections?
makes sense to just have a call between two of us, and you could ask all your questions that you have anytime. We could
Okay.
do that today, or let's say at Wednesday.
No, probably not today, but okay, yeah, I'll write you.
I won't be available tomorrow, so Wednesday anytime, almost anytime.
Okay.
Okay, thanks, Shamil. Let me share my screen then. Okay, so last week, the first change was to include Gemini to a chain spec. It was already built. We just had to add it to the source code, similarly to what we had for Gemini 1B, and specify bootstrap nodes so everyone can join it. Then there was a small update about Windows certificates. We had updated that, and the hash was different, so it wasn't able to sign the executables. Then there was an interesting fix. Basically, we had a small mismatch between client and runtime. Initially, when we start the chain, we usually start it in a way that only allows building blocks by one farmer, and solution range adjustment is disabled. So we always have the initial solution range, which means 1 megabyte, and the chain actually is bigger, like it's growing all the time. And that means that we basically produce block every time slot, and that's how we can see the history quickly. However, that also means that we cannot release it as is to the network, because the history size will be 1 megabyte and will be thousands of farmers that are trying to produce a block will have thousands of forks, and there is a limit in Substrate on how many forks it can actually maintain, and there will be problems. So what we do instead, when we enable solution range adjustment, we have a call for that. Let me see. Yeah, basically this thing is called from the runtime call, this method, and it will enable solution range adjustment, and we have an option or like a possibility to override what will be the solution range after we enable it and what will be the range for votes. And there are actually two cases how that could work. Let me probably open it separately so you can see it better, maybe like this. So a little bit better. Yeah, basically we have two cases. One case, if we have already planned to change our solution range in the next block, in which case everything works as usual, just the value is updated in place. However, most often the case is that we do not have anything planned, so we need to like override it in the meantime. That's why we have this storage item, and we also update the current value such that in next block it will be applied immediately. However, we were not setting this consensus log digest item about next solution range, such that the client, when it verifies the header values, it doesn't actually see the header value that something will be updated about solution range in the next block. So it still thinks that the solution range is the same as before, even though it was updated in runtime. And that caused basically impossibility to build blocks because client refuses to verify it, even though runtime agrees that it is correct. So what we did in that case, that happened on Gemini 2A. And what we did instead is we basically rolled back one block before that adjustment was applied, and then we deployed this runtime upgrade with this fix that in second case still sends this or like sets this digest item in the header, and then we built a fork from that branch, and then the whole network switched because that becomes longer, and everything is basically fine. But that was an interesting tricky situation that we didn't account for previously. This was basically a fix for that issue. The alternative was we actually set a digest item, like special digest item, that there was an override. However, we didn't account for that either in the client. And if we use that instead, which was possible, we would require everyone to update their clients, which is undesirable. So this way, we basically transparently fixed it for everyone. But it was an interesting situation. Does it make sense? Any questions about this?
What a great thing to
This
not
was
have a
the-
finality.
Well, actually, we do have a finality. Like, basically, we have an archiving point, and we consider the block that was archived to be finalized. So we kind of like introduce the finality, even though it's not the same finality as when you have like majority of validators or anything like that. But this was like one block. We were not able to build any more blocks, so it's not finalized either way. Yeah, and then about our memory usage, there is this issue upstream that Ivan has created, and he did some benchmarking, and he also added a snippet of reproduction case, how we can reproduce large memory usage. It's kind of ridiculous how much memory it actually uses for this case. And we've got some explanations. There are basically some data structures which are quite big. And when we have big batches, it consumes a lot of memory. So Ivan decreased batch size in his pull request. But we also noticed that there is quite a lot of memory that is not reclaimed by the system allocator after a commitment happened. And turns out that they do have some kind of overlay system in the database that like pre-allocates some amount of memory to be efficient later. But in our case, it's actually not necessary because the most writes we are doing is during initial recommitment, like when we create commitments for everything in big batches. And after that, we are just doing small incremental updates, which do not require all of that pre-allocated space, but it is still in memory and used and is not available to anything else. So the small workaround is to basically reopen database. We basically do recommitments, close it, and open it again to like free all of those overlays, and then we basically continue from there. So in my case, right after this, like initial recommitment happens, and memory usage a little bit settles. These are the numbers. This is the first number that we had before on Linux with Gmalog. And this is after overlay, after batch changes from Ivan. And this is when we reopen databases. In practice, over time, it still consumes a little bit more memory. So in my case, it was like up to 1.3 gigabytes, like after, I don't know, half a day. But that is about where it is. And it will be a little bit more on other platforms because not all allocators are very eager to free memory to the operating system. But the numbers are clearly much better. And we'll probably later do something about it upstream. They already have, like, we'll add a patch, but when it will happen, we'll not know. So we need to do something in the meantime. Yeah. Overall, we kind of mitigated the problem of memory usage, I think, to a large degree, and that's what matters.
It's probably a terrible question, but did you consider switching back to the RocksDB?
We did. It has its own problems. It takes a lot of time to build. It is also not like it is not designed for our use case. So we are just switching to ParityDB everywhere if it works, and it does seem to work. There are just some how to call it, like
Rough
child
edges?
problems. Yeah, rough edges. Like I don't think anyone uses that except the substrate itself, or maybe something in Polkadot, and that's why we are hitting some of the edge cases that were not actively like used before. So it does work. It just like uses ridiculous amount of memory by our standards. Nevertheless, I think we can improve that. Ivan has already done a lot of improvements upstream, and I think we'll continue doing that. Yeah, and it helps us in other ways, so why not? But that was a fallback. Like if we were not able to do anything about memory, we would definitely switch back to RocksDB.
This database reopening hurts my engineering feelings for.
I know it's not elegant, but it does work. Does work very well. And for this week, I think I'll start working on the next version of the consensus. I was reading some background materials last 2 days, and yeah, we'll see how it goes. Any other questions to me about any of this? All right. Daria, what do you have to share this time?
So I have applied to the consensus V2 specification some of the comments that Jeremiah had from our previous meeting, and all the rest of the last week I have spent on reading lots of papers and posts and Ethereum research, GitHub, and so on and so forth about the polynomial commitments. And I think I have the one scheme pinned down, though it's not. I think it's going to be taking a lot of time. But the issue is that I can do, like, I wrote up the complexity of all of those operations, but we will have to actually see how much it takes in practice. Like,
Do you mean to
in actual
implement
time.
a lot of time or
No,
just
in run.
execution? Okay.
Yeah.
Is
Because,
it like order n or like order n squared?
so there are
Complexity?
different parts of it have different complexity. So it is, I posted it in the research channel, and there is like a cost analysis of the different operations. So the complexity of commit is linear to the degree of the polynomial, but the degree of the polynomial depends on how many pieces we're going to want to fit into the same segment, for instance. There's also one thing to decide. Then also some things that are dependable, that can have different complexity, is the way that we may decide to do erasure coding for this, which is also something to evaluate. So I have put some approximate costs based on papers in terms of big O's of those operations. We'll have to actually see how much that takes in practice, and which would be the answer, how viable is the scheme that I've came up with. And
Awesome.
then
Okay. We'll take a look at
we
that.
will take a look at this on Wednesday, and before that, I will take a look at the DSN things that Shamil wrote.
Did you get a chance to look into the paper by Catalano about the most recent one on the linear map commitments?
Which one is the most recent one? I have one that is vector commitments and their applications.
The next one after that.
Oh, okay. No, then not.
Okay. I think that one actually is going to be less relevant. There was because in this more recent paper, they talk about how that paper is theoretically sound, but practically very inefficient. And I think this new paper is trying to resolve some of those actual real world implementation challenges.
The best paper that I have found to be useful is the aggregatable subvector commitments for stateless cryptocurrencies by Ellen Tomascu and Vitalik. It has a lot of stuff, and it actually has the big O analysis of all the things they do, which was great. Which just kind of helped me pin out the more or less final scheme that I have.
Cool. Alan is actually just right down the road from me here. He was at VMware, now he's at Aptos. But yeah, maybe we should talk to him.
His posts that he has on his website, which are like short, kind of cleaner, for general public write-ups of the papers, great. I think that was the time that I have came back more times during writing. The ones that I have opened the most was his work.
Yeah, next generation of Intel processors supposedly will supposedly have 60 gigahertz turbo boost. So that's something we will probably need for all these schemes to work.
Yeah.
Okay, anything else we need to discuss as a group before we close the recording? All right, we're a little bit early today. Thanks everyone for discussing. Thanks everyone for watching, and we'll see you next week.